Yo, what's up, everybody? Welcome back. Today we are working on Perlin noise as a way to mess up barcodes that we're generating for neural network training. The idea here is that I want to take my phone, scan stuff as I put it in my fridge, and then we can do things like say, here are all the things you've made before, and here's how much of all that stuff you have, so you can make these subset of things that you've made. Or like, hey, you're out of milk, you should probably buy some, and here's a link to the grocery store where you can like put in an order. All of that stuff. And we tried like doing a little bit of like by hand barcode parsing, but it wasn't like super trivial. I have like some photos of things that I took in my house, and there's just like a lot of interesting pieces to notice here. Some is that motion blur can make it so that the dark sections are not very dark. Sometimes there are some like pretty heavy obstructions of the bars themselves. Sometimes the bars aren't even black, but they're like mirrors. They're not really straight, right? If I like hold my cursor on this and scroll up, like we're really like moving between bars. Sometimes they're like crinkly and reflective. There's all sorts of things that make this like a little bit more complex than you would think. And so we are training a neural network to learn how to like parse these codes for us. And as part of that, we want to like maybe work our way up to figuring out what is like the simplest network that will still do what we need it to do. And I suspect that that's going to involve some form of predicting which bar we are in more than like the actual codes themselves, which means that like we need data that has barcodes as well as the individual bars in them. Doing some Googling, this probably doesn't exist because who would want this, right? This is like a well-solved problem, and like people have strategies for this, right? But like the data sets that we could find, they have like numbers, like the codes associated with the barcode. But we want to do something a little bit different. So instead of me painting every single code by hand, taking photos and painting them and all that, let's just generate them, right? So we've been kind of working on like taking a random barcode and slapping it on top of an image. The idea here is that eventually we can probably like make this look a little bit like a label on a thing, right? Especially if we use like, we have like masks of this like orca, right? And so we could do something like use the background of the orca to make it look like some sort of structured background for this thing, and then put this on top, and that'll look kind of like a label on a thing. Maybe, I don't know, we'll see where it goes. But today the thing I want to tackle is the warping. So specifically, like on curved surfaces here, our codes are like bars are not straight. If we want the neural network to learn to identify bars, we can't always feed it perfectly straight ones, or it will learn to abuse that fact and fall over when they're not straight, right? And so what I'm thinking for this is we can use this thing called Perlin noise. There's other types of noise, but this is kind of like the base of a lot of like games programming, where like you take a thing that looks kind of like shit, just like kind of like random shit, but kind of like structured random shit, right? And you use this to like do stuff. So you could imagine like thresholding this picture and using it as a mask for something, right? What I want to do is I want to generate stuff that looks kind of like this and use it as like offset vectors. So the idea here is that this is like a contiguous thing, which is a very nice property. Every pixel will be, close to the pixel values around it. And that means that we can do stuff like create a crinkly bag by applying a kind of like semi-high resolution Perlin noise to this thing and using the output of the noise as a X or Y movement. And then if we just do that twice, we should be able to get something kind of interesting. I suspect that if we do that at low, like resolution is wrong scale, I guess. Right? So if we have like really, really tight noise or really like expanded noise, I guess, we can kind of use the really low res version to generate like a big offset that's kind of like not perfectly aligned, but right? You can imagine like if you had one of these like, God damn it, Wikipedia, let me zoom in. Right? Like if we had like just this section kind of covering the whole barcode, you could imagine that would do something interesting. Yeah, so that's what I want to do today. So Perlin noise, what the fuck is it? I don't know. But this Wikipedia page tells us. So my understanding from skimming this page a little bit ago is that you just kind of create like a grid of arrows. And at each point in the grid, you kind of just like interpolate the 4 arrows, and then you get this. Should be pretty straightforward, right? It seems pretty straightforward. And so then also, if you are you're interpolating the dot product of the 4 arrows or something. So if you're like directly on one of the corners, your dot product with everything will be 0. So it should be like something like that. Okay, let's get moving and see what happens. So everything we're doing is in OpenCL land right now. Just because that's where like our neural network training is going, and so it makes sense that if we can kind of do on-the-fly image generation, it's like more likely to work if we do the image generation on GPU and OpenCL as well. I'm hoping that means that we'll be able to generate like lots of images very quickly, but we haven't really got there yet. But somewhere we have like barcode generator who runs like an OpenCL kernel, which is like a thing that runs for every pixel, or in our case, it's every pixel, but it could be just like any of, if you have like 1,000 things to do, the GPU will execute the kernel for each of the 1,000 things, hand wavy. And so we can define that thing as pixels. Do we want to do this on top of the thing we're already doing? Probably. Probably the more that we can shove into the same kernel, the better. So we already have the thing that's generating the barcode here. Maybe it would be interesting to just throw in on top of this thing, Perlin noise. Sample Perlin noise. Sure. And he's gonna give me a floating point value, probably. And what are his parameters? Probably an X and a Y, right? And what is he gonna be doing? He's going to be like, I guess we need our grid of vectors. So where does this come from? Is this like a pre-generated thing, or is this something we can like mathematically compute? If we have like a preset, we have like, we've looked at like pseudo-random number generation before. So presumably we can define a grid and a PRNG, and that way we don't have to like take all these vectors, write them out to memory, and then sample them later. We can kind of just be like, we can like give the parameters to the PRNG to calculate this stuff, I think. So what does that look like? Also, I don't know how to like include other files yet, but we'll get there. So I guess let's start for now with, where was the random stuff here? Rand.cl. Can we just kind of copy paste this stuff for now? Because I don't know what to do with it. We want a way to get floating point between 0 and 1, probably. -1 and 1, maybe. So let's kind of just slap this in here for now. So we have, how did this random stuff work before? We had, and I'll put a fix me, include rand.cl instead of copy pasting. I just don't know how to handle includes here yet. This is a problem for later. So we probably call phylox 2x32. This will give us a random value as a ulong, and then we probably call ulong to float to turn that from 0 to 1. Probably. So what are the parameters here? We have counter and key. So key is seed. So we have, what were the types of those? Counter was probably U64. Ulong and uint. Okay. Okay. So here we are probably sampling from a spot on a grid. So we probably have to determine the grid size, right? Grid. So if we have like a picture, I guess we probably want this scale to fit directly in picture size. Maybe not. Maybe not. So can we just call this a cell width? Maybe, right? And then our X and our Y will kind of determine which PRNG value we are using. That seems pretty reasonable. And if we wrap around and end up negative, That's probably fine. Now, is it easier for us? So we do need to, like, if we're using like one counter like this, that's like incrementing for each value that we're sampling, we need to determine like the wrap width, or we need like an X and Y counter that we like increment separately and combine in some way, right? Because if this grid, you can imagine this grid could be infinitely large, in which case you don't really have a wrap width, right? Which is kind of interesting. Yeah, how do we want to handle that? So if we were to have two PRNGs, how would that work? We want like one vector from one individual point. So you would like maybe multiply them and truncate is probably a reasonable thing to do here. Yeah, that's not crazy. So you have like two counters, multiply, truncate, and then even there, you could actually just have this as like counter offset, right? And even then, you could even just pass in seed, and we could just do that from our X and Y, right? So instead of permutating, yeah, so we could kind of say that like for this set of random numbers, we will look at this corner would be like 0, 0. This is 0, 1, 0, 2, 0, 3, 0, 4. We use that to generate a counter value for the PRNG, so we multiply the two numbers together. That doesn't work though if one of them is 0. Because then if we were to do multiplication, every single one of these would be the same. Adding isn't great either, right? Because you have like 0, like then 0, 1, and 1, 0 would be the same. What if we use one axis to initialize a PRNG for the second axis? Is that stupid? So we go like, as this is like we have Phylox 2x32 X with the seed. And then this is seed 2. Yeah, we could use like the yeah, there's maybe something here. Let me think. Yeah, so you could like sample yeah, so you get this seed from this. Then you have like Y and seed 2 in some way, and what does this give you? If we want to sample like pairs of numbers from this PRNG, which we do, we want like X and Y values for the vector as well. I wonder if you do something like this. I'm spitballing. Then we have like U long to float here. Okay, so this is going to be like our X direction. This is like our VX, VY. I don't know, man. Right? Is that crazy? Is this crazy? Right, so we start with... This gives us a different PRNG per column, essentially, right? We're like generating a random generator per column. Then we jump into that column, at some point and sample 2 values from it. Yeah. Yeah, that seems reasonable. So these vectors, these need to be probably in the range -1 to 1, right? So this is 0 to 1. So we times 2 minus 1. Right? Something like this? Sure. Sure. It would be cool if we could render these vectors some way. We also need to take into the scale into account. We haven't looked at cell width at all, right? So this is probably, what? We have, we say our cell width is like 10 by 10, right? So as we walk into this thing, boom, 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 we need this to turn into all one number, which means that we divide x by cell width here. So I guess we have like cell x is x over cell width. We have cell y is y over cell width, because we're calling them square for now, kind of like forcing that. Then we use cell x here, so that every cell has the same generator. Okay, and then we use cell y here, and it looks like we want these as u longs, actually, because they're being used as inputs to the PRNG. And then we have cell y times 2, cell y times 2 plus 1. Yeah, okay. Cool. So then we should be able to just render this as color for now. Except we only have floating point, fuck. Let's just first, if we render only one of these things, Vx or Vy, we should get like a pretty good idea if these are truly random, right? So we'll render the horizontal thing, and we should see this in chunks of 10 pixels, all like relatively different. That's what we're kind of hoping to see here. So let's say that here, instead of whatever the fuck we were doing, can we just be like, sample Perlin noise at our, like, global ID percent width, global ID over width for XY, right? Because, like, we're feeding in a, like, 1,000 pixels at, 25 by 100 or something. What am I saying? 10 by 100? Something like that. And then seed here we need, which isn't passed in yet. And then cell width also isn't passed in. So we need these guys. It's uint seed and uint cell width. Okay. And then can we say, yeah, I guess these guys should be uints here, huh? Not floats. Probably. Maybe ulongs? And then we just say, like, ret at global ID is equal to this, and then return. Okay, so this guy's mad because he says unknown error, but I know that that unknown error means that we didn't pass in enough parameters here. So when we run this thing, we have 2 new parameters. It's 2 uints, 0 and 10, right? Cell width and seed. Okay, so that's a pretty good sign. So every 10 pixels here, probably, I'm assuming, we have what looks to be, like, fairly random shit. I think probably we actually want a scale that's, like, way bigger than 10 for this initial experiment. Let's say 100. Okay, so that seems good to me. We could also take out the conversion from -1 to -1 to 1 and start 0 to 1, because I think that might, like, that just, like, looks a little bit more presentable here. OpenCL works kind of like OpenGL once you build a supporting code for it. Yeah, it's interesting, for sure. It's the fragment shader stuff does a lot of heavy lifting for you. I think that we don't get access to some of the like 3D pipeline stuff that you get, like auto depth sorting and stuff. I don't know if that's implemented in OpenGL as like things that you could write as kernels, or if there's like dedicated GPU hardware for depth sorting. I would imagine that there's dedicated hardware for it because like GPUs are meant to do some form of rendering. But who knows? Okay, so we can look at the Y as well. Not that it really matters, but we could confirm. Right, so it's kind of like the same shit. And so what do we want to do here? We want to use this to do something. So they're saying once we have a grid of numbers, can we render us taking the dot product of our pixel position with that thing? So our pixel position is so in this scenario again we have 10 by 10, right? So there's like 100 pixels in here. And so if we're like at this pixel, we need to calculate the distance to here, 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 and here. Right? So I guess we define we need like to create these vectors for all 4 of those corners. Right? So I guess we want like I almost want to make something that like tracks that for us, right? That's like Perlin corners or something. I don't know, man. And he has like, float to top left, top right, bottom left, bottom right. I guess it's a little silly for us to pre-calculate all of these guys, store them in memory, and then copy paste them out. Like we probably can do this sequentially, probably, right? So it's almost like we want to go for int I is equal to x. I is less than x plus 2, I plus plus. And then for j, we almost want to make this like get like sample Perlin vector, Perlin grid vector or something, right? And this is this should be cell x here actually, not x, I think. Right? And this should be cell y, not cell x, and this should be j++, not I++. Dude, fucking for loops, man. And then, I guess like really we should do x like yx. Not that it really matters, but just for habit, it's better to do x on the inner. Okay. So this means that for each of these, we're gonna be making like float to sample Perlin gradient vector at cell x, cell y. I think that makes sense, and then seed here. And then we can kind of take all this stuff. Can you do it like this in this language, or do you have to do in C? I think you have to start by doing this, right? Float 2 vx vy or some shit. Okay, so then here, for each of these cell positions, we sample the gradient vector at ij with seed. Okay, that's good. And then what do we do here? We dot product. Is it the difference? So working out the value of any candidate point, first find the unique grid cell where the point lies, then I define the corners of that cell. Next, for each corner, calculate an offset vector. Yeah, so our offset vector, we need to normalize this thing as 0 to 1, presumably. maybe it doesn't matter. I mean, probably. So, are we summing them or what? We're interpolating. Interpolating. So the maximum dot product would be 1.0 if you're 1 and they're 1 and you're pointing in the same fucking direction. So I guess we normalize 0 to 1. So we have offset x pixels, sure, is x minus cell x. Okay. I don't know in C, does this get like integer promoted? I don't remember the fucking rules. Zig's corrupted my brain to assume that the type system will work reasonably. If you have like C integer promotion, do I have to like manually cast uints to ints when I do subtraction like this? This sounds like a fucking ChatGPT question. If I subtract 2 uints in C, do they get int promoted? They do not. But they... Does that matter? Because when you cast from uint to int, like, subtraction in uint and int with wrapping is the fucking same. Right? So, like, when you cast, it's fine, I think. Yeah, I'm pretty sure that's right. I think it's fine. I think it's fine. Because it just wraps. Pretty sure. So then what do I do here? I have my offset as an integer. So here I can be like, offs x normalized is offs x pixels as a float, cast from an integer, so with negative numbers is fine, over cell width. Okay. So then we like have the grad is this. Then we like dot product. Is it us onto them or them onto us? Does it matter? It's probably us onto them. We take the dot product between its gradient vector and the offset vector. Is it the same? Am I stupid? Is the projection of one line onto another? Like, if I have this, is this the same as this? Probably, right? It seems pretty symmetric. Probably. So we can probably do something like this. And then I guess we want to do like, they say to like interpolate between them. So I guess we probably want to do like bilinear interpolation, but like smooth. Maybe. We could start with a lerp. Yeah, which means that we probably want all 4 corners calculated so that we can lerp them easily. I think. So we can have like corners or like vowels. I don't know, man. 4 of them. And then vowels index is equal to 0 or something. And then we have like vowels val index is equal to this. Vowels index plus equals 1. We could do something more intelligent here, right? Like we could do like single for loop here. For int I is equal to 0, I is less than 4, I plus plus, and then we can like figure out the x and y. So we sample like grad x is cell x, what, plus I% 2, and grad y is cell x plus I over 2. I think something like this, right? Something like this. And then we use grad x and grad y here. Or something. I don't fucking know, man. I don't know. And then we do what here? We like bilinear interpolate. So can we just lerp for now? Do we have lerp in here? Yeah, we do. Where is it though? Because in this language, you need to make sure that definitions are at the top of the file because it's single pass. Okay, so we do like A is lerp vals 0 and vals 1 by like x like x lerp t is a bad name for this, but fuck it. So this is like x% cell width as a float over the cell width. Yeah. And then ylerp t is the same. And then we'd have A and B. We lerp vals 2 and 3 here with X. And then we lerp A and B with the ylerp. Yeah, something like that. That's like a maybe does something, right? Be interesting to look at that. Okay. Interesting. So there is like some semblance of patterns in here. I don't like how in a column, within a column, we're seeing like repetition, which I don't like, right? Like we're kind of seeing like this, and then this, and then this, and this. Like they all are kind of the same. It's almost like we're moving through like some slice that we're not supposed to be. Why is this not contiguous? Let's just do a stupid and invert the lerp. I don't think that really matters, but it might. Yeah, that doesn't really do anything. So, is our cell calculation correct? Seems like it is. This is a truncating division. We could do something like return cell x or something. Just to make sure that we see like kind of incrementing on x, so that seems kind of right. And then y, we should see incrementing on y. Boom, 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 boom. Nice, okay. Grad y is wrong, you're using x again. So true. So true. Okay. That looks like something. It doesn't look good, but it definitely looks like some sort of like continuous motion. And I assume that if we improve the lerping here, it'll work a little better, right? Because we're supposed to be using like smooth step or something, right? So we shouldn't be seeing these like harsh lines like this. It should kind of be a little bit more like, It's not, it's square, so cell width on both is fine. Yeah, true, but here I was using cell X here. So I think this is like relatively correct. We just need to do like smooth step now. Which surely is not that hard. Actually, they're using something even more crazy here. Can we just call this like Perlin interp? So they're saying A plus smooth step T times B minus A. Right, that's kind of what they're saying. And then we need float smooth step. And what's this? This is like essentially a sigmoid, but like this. So it's 3x squared minus 2x cubed. T3, T times T times T. I guess we do T2 first, and then T3 is T2 times T again. And then this is 3 times T2 minus 2 times T3. Okay. And then here, these lerps becomes Perlin interp. Boom, boom, boom. That doesn't look good. Too many T's on T2. So true. And then why did I do T times T3? 2 times T3. Just fuck that up in all sorts of ways. Woo! And then probably this is outputting -1 to 1, right? So we probably want to do like +1 divided by 2 to get it back in the right range. With F's in this language, because otherwise it just does doubles, because fuck it. This seems weird to me. The fact that there's like so much dark. I'm a little concerned about that. I'm not really sure if this looks wrong. It seems very extreme, yeah. I agree. It's like capping out more than I would have thought. Just making sure that it was like that doesn't cause any problems, but yeah, it's fine. Yeah, it does kind of feel like this shit's growing too tall. Can we log what this thing is? Maybe do this. We are seeing numbers like significantly above 1 here, which is not what I expected. Right? So does that mean that our offsets are too big? Or that our gradients are too big? Oh, these gradients, I guess, could... No, Pythagoras? A squared plus B squared equals C squared? So these could be root 2 in length, right? So we need to divide this by square root 2. But I don't think that solves the problem exactly. Because these guys are still, like, very large. I don't really understand why. Because I would think that the... Can we log the gradient and the offset here? Dude, it's so sick that you can just printf in these things. That's crazy. Grad 0, grad 1. Let's just see what we're looking at here. So it's the offset is like fucking mega big. Oh yeah, I'm a dumbass. This is stupid. X minus cell X is crazy. This should be X percent cell width. No. This needs to be, like, are we even using... Here we go. This is where it makes more sense. So gradient X and gradient Y are, like, the corners here. Right? So this is... X over cell width and Y over cell width here. And then grad X and grad Y here are times cell width to get back into pixel position. Yes. That sounds kind of right. Now are these numbers a lot more reasonable? Still seeing like 6s in here. Yeah, because why are we percenting here now? This is subtraction, no? There we go. These numbers look a lot more sane. These are like numbers between 0 and 1 everywhere. Does that look more sane? Oh, yeah, wait, that's looking pretty fucking hot. Pretty hot, dude. I worry that the dark sections didn't look dark enough, which is interesting. If A is less than 0.1 or B is less than 0.1, can we just kind of printf that something happened? Okay, I mean, that is happening. They are getting very small. And can we say if, you know, float ret is this? Oh, maybe the range was wrong. Maybe I was wrong about the negative 1 to 1. Maybe we were just assuming, making an ass of me. No, they do get negative sometimes. Okay. So, scaling did make sense. I think it's like this. We did it the other way last time, but like whatever, it's the same shit. Yeah, the values are very not extreme. Just kind of like in general, which is interesting. Yeah, isn't this like doing something like... This makes sense, right? Because they were saying in the Wikipedia page that going through the corners should be 0. I think, right? Maybe not. Because you're kind of like at this corner, your offset vectors are like 1, 1, and 1.4, right? Or like root 2. So the dot product on all of these vectors is always going to be quite high, right? So it's not like going through corners guarantees 0 or anything. And so getting like a 0 would actually be like pretty rare, if I've understood this right. So let's like read this a little bit more carefully. For working out the value of any candidate point, first find the unique grid cell in which the point lies. Okay, then identify the 2 of the end corners of that cell and their associated gradient vectors. Yep. Next, for each corner, calculate an offset vector. So displacement vector from that corner to the candidate point. Yep, okay. So is that what we're doing? We're doing us minus them. Yep. For each corner, not that it really matters, I think it being backwards would be fine. For each corner, we take the dot product between this gradient vector and the offset vector to the candidate point. Yep, this dot product will be 0 if the candidate point is exactly at the grid corner. Yes, okay. For a 2-dimensional grid, this will require 4 offset vectors and dot products, while in 3 dimensions, it's, yeah, sure, whatever. Final step is interpolation. Interpolation is performed using a function that has 0 first derivative and possibly second derivative at the grid nodes. Therefore, at points close to the grid nodes, the output will approximately be the dot product of the gradient vector of the node and the offset vector to the node. This is kind of what I was confused about. This is what I was expecting, right? So the final step, but like this is not true if we're adding in all of the other guys. Oh, but I guess we're interpolating, right? So we're supposed to be saying like, hey, if our x is 0 here, we should be taking like almost exclusively vals 0 and vals 2. And so these will both be close to 0. And then we interpolate those, and that's like fine. So is this interpolation thing correct? Okay, let's think about this. So if x is 10 and cell width is 10, we will be right on the corner. So we'll have 0 out of cell width. If x is 5 and cell width is 10, we should have 5% 10 is 5 out of 10 is also 0.5. And then if this is 9, we have 9 out of cell width. I guess we never get a 1.0, but that's okay because that's the same as a 0.0 on the next pixel. So I think that's fine. So then the question is why are we never seeing 0? Right? That seems bad. Can we see what's going on? I guess we should double check that sometimes the offsets are 0. So x minus grad x times cell width. So sometimes I will be 0 here. So this will be x over cell width, which means that this will be x over cell width times cell width, which means that this should be like x minus x. And sometimes. If x offs x pixels equal to 0, and offs y, px equals 0, printf, hell yeah. Right? This should happen sometimes. Right? That does happen. So then in that case, why don't we feel like we're seeing 0? You know what I mean? So can we do a bool has 0? And can we just look at what all of our values are? If has 0, can we printf like let's look at x lerp t, y lerp t, and ret. Maybe vals 0, vals 1, vals 2. Vals 3 and ret. Fuck it. So 1, 2, 3, 4, 5. So this, oh, because 0 is 0.5 because of the scaling. Of course. I'm a dumbass. Because 0 is not 0. This is supposed to be negative 1 to 1. And so maybe it's that the ones are like unlikely, right? So can we actually like multiply this by like 5 or like 2 even? Maybe, you know what I mean? And then clamp it? Maybe? Yeah, these values are always very small. That's interesting. Okay, maybe that is like kind of correct. And I think technically we could be getting values bigger than 1 sometimes because of the fact that we're not dividing by square root 2. But that looks like Perlin noise to me. Can we increase the scale? Barcode gen? Yeah, here. It's weird that it looks so blurry, but I think it's supposed to look blurry. It's just kind of the way it looks. I think that looks pretty Perlin noisy to me, right? That looks like similar shit. I'll take it, dude. I'll take it. Okay, so that's a success. And I guess we want to use this to like fuck up the bars in some way, right? So I want to do something like do we have seed being passed into this thing already? I think when we generate barcodes oh, they're used as for the parameter generation. We can put Perlin seed in here probably. U32, I think. And then we go like Perlin seed is equal to RNG interface int U32. And then we have Perlin seed is equal to Perlin seed hype. Okay, and then here we should be able to pass in params Perlin seed here. Nice. And then I guess we can throw the scale in here as well, but maybe we'll do that later. Okay. So what I want to see here now is in randcl, sorry, in whatever the fuck this thing is, generate CL, nice. Instead of just using the, like, outputting the Perlin noise like this, we can sample Perlin noise and use it to adjust our X and Y sample positions. So X, so can we just call this like X offs? Ooh, this is only giving us one dimension of offset though, which is a little bit interesting. We can start there. You know, but we gotta figure out what we're doing with this shit after. I think this guy has to set initial Perlin C to 0. This guy's mad because there's a redefinition. God damn it. Everything's so hard. We should have smaller scopes. But we do see some sort of waviness here, which is pretty hype. Right? We're starting to see, like, you can imagine that this is like a barcode on some sort of like crinkly shit. So probably we probably want a parameter for like how much we want to do this shit. But this is definitely starting to look like what I wanted. Hype. So can we like how do we handle the fact that we need 2 offsets now, right? So we need these things not to be correlated, really. Yeah. So in this Perlin gradient vector generation, we used the cells of the grid plus a seed, and maybe we just throw in an offset on this. And use that, or we just use a different seed. I guess just a different seed is reasonable. If we just do sample the grid with seed and seed plus 1, then maybe that's fine. Maybe. It is a little annoying because we're using seed plus 1 in here. No, we're not. We're generating seed 2 out of seed. So seed and seed plus 1 is not crazy. Not too crazy. And here we should see like the top and the edge of the barcode now is not like perfectly clear. And we can start like parameterizing this probably. So can we have in here, we'll call this Perlin cell width like this. Okay. And then we'll have like noise X scale and Y scale here. And between the 3 of these, we should be able to start getting like really crazy. So scale here is like a little bit of a confusing term, because scale could mean like the scale of the Perlin grid, or it could mean like how much we're planning on moving. I guess it's fine. I guess it's fine. Okay, let's add these to the parameters that get passed in here. So parameters, we have Perlin seed. What do we fucking call this shit? I don't know. Like X noise scale and Y noise scale. These are F32s. And then we'll put these in our randomization parameters as like X noise scale range. Okay. Cool. So rand float between self X noise scale range 0, self X noise scale range 1, and just hit some Y's on here. X noise scale goes here, and Y noise scale goes here. And then it would be nice to like put these into the GUI as well, so that we can kind of just like edit them on the fly, which we should be able to do. We need like a better Perlin params. We need like a better way to visualize this stuff in the GUI for now. Well, or sorry, later, but for now we can kind of just do this. So we're gonna have Perlin seed. We have noise, X scale, and Y. Seed is going to be a like U64 dragger. Generate Perlin seed. Generate Perlin X. Generate Perlin Y. And then this parameter isn't a float when we use this. It's like every 20 pixels we will update this thing. So we need functions that will create actions out of these things. So it was generate Perlin X, generate Perlin seed. So the GUI framework will ask, he'll say, hey, someone moved this float dragger, and can you like choose how you want to handle that thing? So like, you know, validate that it's a valid parameter, clamp it, whatever you want to do, apply whatever like changes you want to make to your UI when actions happen. That's kind of like the job of this section. So because our GUI framework, he doesn't like to modify parameters directly, you know? Generate Perlin X and Y. He kind of works off the idea of retrievers. So even though he has the value that's being modified here, he doesn't ever change him. He only looks at him. So here we're like image view updater params X noise scale is val, and then we update. Fucking trigger an update, regenerate this shit. We do the same for Y, like this, and Perlin seed. All right. That should start to look pretty good. Here we need to set our randomization ranges for these things. So we had X noise scale range. I think that we want this to be 0 sometimes and up to like a lot, 10. Right? Y we probably want also in the same order of magnitude, probably. And then, did we not have scale in here? Scale seems very important as well. Perlin grid size. This thing needs to be in here. It has to be. Has to be. Do they have like int range? Nice. At most U32 Perlin grid size range 0. Perlin grid size range 1. Oh, I'll just shove that in here. Okay, and so he should be using that when he generates this thing. So here he has params, Perlin grid size, and then did we add, I think we had 2 more float params here, right? X noise scale and Y noise scale, I think was what these were. All right. So this thing we will have, you know, maybe like 10 to 100, or like even like 1,000, maybe. Okay, Perlin grid size is 10 or something. I don't fucking know, man. X noise scale, maybe like 5s by default. And then we should get the scale argument into the GUI as well. But let's do that in a second. Someone's mad that this guy should be U32. So true. And then this guy should be a U32 here. which means that this should be a U32. Okay. So what we should see here is if I start like moving the Perlin seed around, we start to see this guy kind of whoop, 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 whoop. We can kind of reduce the X scale down to 0, right? And the Y scale down to 0 as well, right? We can kind of like change the like magnitude of this thing. And I want to add the grid size here as well. So generate Perlin grid width. And then somewhere we have like here, this is Perlin grid size, generate Perlin grid width like this. We can use the same drag parameters here. And then we need Perlin grid width, adjust the Perlin grid width, and calls update. U32's here. U32's here. Who's he mad at? The fuck? Expected type F32 found U32. Expected U32 found F32. U32. U32. Oh, here. Okay. So now we should be able to like kind of make it so that this thing has like kind of like lower resolution effect. Right? Which is kind of hype. Oh yeah, look at this. Look at that, dude. That's perfect. That's actually so good. Right? We've got like this is what I was hoping, right? At the very beginning when I was saying that we could kind of like simulate something that's kind of like a slight bend in the bar with low res Perlin noise, right? So we have like grid width all the way up here to like 400 even. And with like the effect here, we probably want it to be a ratio of the grid size, probably, right? But look at that. That's beautiful. That's exactly what I was hoping for. Look at that. Here, can we unrotate this guy a little bit so that we can kind of... Oh, I think the... That's funny. I think that the Perlin parameters might be related to image space, not like barcode space. But yeah, look at this. So now when I drag up, I guess, like you can probably see like the bend on something like this where... Oh, I can't scroll like I could in the other thing, but you can see like here, it's bent so far to the left and then it's come all the way almost back. I think that's pretty fucking sick, dude. That's really good. Cool. I consider bar warping a success here. So we need to at least set reasonable randomization parameters. I do think that the amount of offset needs to be related to the grid size. It just kind of feels that way. So let's calculate the grid size first. Then Perlin, we want to call this like multiplier range almost. X noise multiplier range. Okay. X noise multiplier range here for scale. And then these guys get both multiplied by the Perlin grid size, like this. And then in image gen, when we set these initial guys, we need to go back and play with it some more to figure out what was sane. This needs to get cleaned up. Just like, what the fuck? Float from int, sorry. But something like this. Okay, so right, like this is too much. Right? So I think like 1/10 maybe, right? When this was at like we had the like scale here very large, like here, and then we had this also very large. Right? So like 20 here, maybe a little bit lower than 1/10, maybe. Maybe like if this is like 400 and this is 20, that looks pretty reasonable. And then if this comes back down to like, you know, low, like 150, if we did 120 of this, that's 7. Yeah, I could allow that. We could get even a little bit more extreme sometimes. 1/10 is a lot, but that's kind of like the upper bound of the randomization. So let's do that. So we'll say this guy can go 1/10. Right? So somewhere in this range. And then the grid size 10 to 1,000, sure. And then let's just like kind of like roll the seed a little bit. Wait, why is this so fucked? Oh, because our initial parameters are not that. Okay. How do we make it so that we can like fucking see this thing? That's pretty straight. Pretty straight again, but we do see like a little bit of a bend on this guy. He kind of bends in a little bit. I'm kind of down for more extreme, actually. Oh, here we're seeing some, like, pretty big warping here on Y, at least. Yeah, you know what? There are some that are, like, pretty fucked up in here. Maybe it's fine, right? If, like, that's pretty fucked up. That's, like, really bent. Oh my god, sorry guys. Chat was broken again. So I haven't seen anything for, like, a while, probably. It's fucking something is making it so that if I don't click on the chat, I just don't fucking get updates. That's annoying. Not gonna project it on a cylinder. Yeah, I don't think so. I think that this will probably be like good enough. Hoping. I'm hoping. Yeah, I mean I'll take it. I'll take it. Fuck it. This is fine. Oh yeah, there are some like occasional. Look at that. Womp womp. Okay. I consider bar warping a success. I wanted to do some other just like quick guys here. The anti-aliasing stuff, I was not quite happy with. I wonder if we can find some examples of it looking like kind of fucking stupid. So yesterday we were looking at anti-aliasing. And we realized that like this is like kind of correct in terms of anti-aliasing, right? We have like this thing is like kind of getting lighter and lighter in like fixed increments as it comes down, but it still looks kind of fucked up. And just kind of like looking at pictures, it seems to me like in real life, the gradient of like on to off is not within like a single pixel, right? It's within like many pixels. But like we could do something like just like a Gaussian blur over the whole image is like probably pretty reasonable as like one of the things that we do. So we could do like a little barcode blur, you know? Not sure what you use for Twitch chat, but I think Twitch chat support. I'm not sure what to do. What do you use for Twitch chat? But I think Twitch chat support IRC, so you can spin a terminal with it more reliable. Oh yeah, I see. Yeah, I just have like, I would have thought that just having the browser open would have been fine. I just like pop out the chat in the browser because that's where it comes from. But yeah, I guess. So Gaussian blur. The question is how do we implement this? The obvious thing to do is to just run an image kernel over the barcode, I guess. But it means that we need to know if we're in the barcode or not, which is like a thing that we're gonna have to do anyways, right? So maybe this becomes like a dual pass thing where we maybe even like triple pass or something. If we're gonna run like 4 image kernels over this thing, then like maybe that becomes relevant in some way. But so we could first start by like exporting a mask. He didn't see any of this stuff about the Perlin for more than just distortion or contrast layer. Dirt layer I was talking about. Yeah, sorry. Yeah, as dirt it does make sense, huh? That's not crazy. That's not crazy. Yeah, let's just start. Let's think about this. So we mask off the part that was barcode, then apply an image kernel to the whole image, and only apply it where the mask is not like that crazy. I think that's fine. A little wasteful, maybe, but not the end of the world. The other option is to like intelligently only run it on the part of the image that the barcode is in. But I don't want to deal with that right now. I do not want to deal with that right now. So I think I will just generate a mask. So let's do that. So we'll go barcode generator. As part of this kernel, we will have a mask red. Easy. And we'll just say mask ret is equal to 1 here. Right, so that should, we need to like initialize mask to 0 here before we run this shit, probably. Masking part of the image is the same thing as considering only part of the image. In terms of effect, yes, but not in terms of computation, right? Right, so like, if I am trying to generate like 1,000 pictures at once, I think that we could do less pictures at once in one way versus another. But maybe not. Maybe like, because we already are, for generating 1,000 at once, have to process 1,000 images at once for the first pass. So then like maybe it's fine. Maybe it's fine. Yeah, okay. So here we have mask here, probably. Mask is, you know, create tensor filled. What's the difference between lens and motion blur? Lens blur is gonna kind of be like each pixel kind of gets like a surrounding area, kind of, and motion blur is like you get a streak in one direction. Okay, so dimensions of this thing is just gonna match the dimensions of our like buff. Base dims, I guess, and we're gonna fill this shit with zeros. Okay, cool. And then if we swap, I think if we just write base buff here twice for a second, we should get to confirm that the mask is correct. Yeah, so here he wrote ones over the area that the barcode was in, and didn't touch the rest. So as long as we initialize this thing with zeros, we should be chilling, right? Couldn't you just use the translation rotation scale to figure out where to blur instead of using a mask buffer? Probably, right? Probably. But the mask is going to be useful anyways for neural network training, right? Like we're going to need the mask for like barcode isolation. So I kind of figured it's the same. You are kind of right that like probably memory hit like will generate slower because we're sampling the mask buffer instead of just calculating again. Oh, but like the noise stuff as well, right? Because of the noise, it's going to change. I think this mask buffer will eventually contain like information about which bar is which and stuff as well. So maybe it's fine. We can always change our minds later. But let's do a blur. So is just applying like a normal convolution but masked, right? Which I guess is like not really the same as just a regular convolution. Sure. Convolution, masked convolution. I guess that's like a generic thing. So this should go in like the math executor, and we'll have a masked what's this thing fucking called? Conv kernel. And I guess that goes in like source math conv cl or something. Is that where everybody else lives? Yes. So we have a kernel who is going to be like masked conv. And what are his inputs? We probably have like input buffer. Maybe this is mask conv in place. We can't do it in place, right? Because you would be fucking up all of your other samples. So this has to be a copy. So this is like inbuff. Outbuff. We probably have kernel. And probably like kernel width. You could potentially do it in shared memory, but that'd be quite tricky to orchestrate. Yeah, true. You're gonna be compute bound. The memory latency is not an issue. GPU will hide that quite effectively. I'm pretty sure that memory is going to be like for simple computations. I think memory is the bottleneck. I think, but who knows? What do I know? This is how big the thing is, and what are we doing? It's like, for int I is equal to 0, I is less than kernel width, I plus plus, we do this twice. We run this in both directions. We say multiplier is the kernel at like I guess this is like A. So this is the kernel at I times kernel, or probably J times kernel. No, I times kernel width plus J. Maybe we call these Y and X. Kernel X here, just so I don't get confused. Okay. Oh, kernel's reserved word, huh? Image kern, I guess we call it. Okay. So then how do we determine the offset here? We have like int image x is We have our global ID. Right, we have if this is too out of range, do nothing. You could train straight to the generated images without saving anything to disk. That's kind of what I'm hoping for. I'm hoping that we can generate like a fuck ton on the fly really fast and only hit disk for validation set or something. I'm hoping. So here we're at like we have our uh you know in X, I guess, is global over width, percent width. I guess we want like uint image width. I don't know, center, maybe. Maybe. So this is the image X is the center X. Plus kx minus kernel width over 2. I think. Right, so if this is 0, then we're halfway away. So if kernel width is 3, this gets truncated to 3 over 2, 1. And this is 0, so this is center minus 1. Then this comes up to 1. So 1 plus 1 minus 1 is 0. And then we get kx is 2. So cx plus 2 minus truncated division 1. Yeah, I think that's right. Sure. So this comes from in buff image y times image width plus x, image x. And then we have the sum here. And so we like take all of the pixels around us, we multiply, add them, and then this is going to be like way out of range. So maybe we just huck a float divisor in here as well. You know, that doesn't seem crazy, right? So then we have like out buff at global ID is equal to sum over div. And we didn't do any masks in here, right? So mask here. We look at our position and we say if cy times image width plus cx in the mask is less than 0.5. We're doing zeros and ones, and we only have floats in and out in our like abstractions right now, so this is fine. It would probably be better if this was a binary mask, but fuck it. You know, fuck it. We're using 4 times the width. I don't give a fuck. Return. Sure. I'm not like 100% sure that this isn't right. Yeah, I think this is so far so good. Okay. So we have math executor. This guy needs a masked conv kernel. So I guess we need our conv program here. This is gonna be conv program content. We have the masked conv kernel is conv program create a kernel called masked conv. We embed the conv program content here. And then we assign this here. I guess early return is fine. I thought it was inside your loops. Yeah, inside loop return. I think that's also maybe okay. I mean, they're both like this equal amount of wasteful, I think. In loop returns can fuck up like if you have barriers, right? Because all barriers have to get hit by all threads. Because like for those of you who haven't been like following along for the last like 2 weeks every episode, the way like these like GPUs execute stuff is they actually share program counters between like 30 threads at once or something. So like you have like every pixel is running in another thread on the GPU. And so what happens is if you have like an if statement, it kind of just turns off those threads and keeps running them, right? So any like branching you have is kind of wasteful in that half the guys in your work, if everybody in this group don't participate in the same way, like some of them aren't doing work when others of them are, if that makes sense. So they run within lockstep. And so if you have things like a barrier, like where you say like all of these guys are writing to the same memory, and so we're going to like maybe write to that memory on one iteration of a loop and then come back and like do a second set of operations on that memory after, you kind of have to make sure that like everybody's finished that write, which is confusing because they're running in lockstep. Oh, that's within a thread group, not within a warp. My bad. Thread groups and warps are different. Warps execute in lockstep, thread groups do not. But I do remember seeing that all thread groups have to finish all barriers. Maybe it's all guys in a warp have to finish a barrier, and so they just can't be in ifs or something like that. Something like that. It's confusing. Okay, let's do a like pub function masks conv here. So this is going to return a tensor, probably. And he's going to take in an executor, i.e. myself. And he's going to take an allocator to allocate the new tensor on. And we don't remember his parameters, so can we just like copy paste another one of these? And just kind of... so we have the mask in, probably, and the image in. Image, so this is a tensor, mask, tensor. And we need to make sure that the image dims are equal to the tensor dim, or the mask dims. Then what is in our kernel? Where's this math CL? No, what do we call this shit? Conv CL? Nice, okay. So here we have buffer of image, we have buffer of mask, we have buffer of return, we have uint of the image width. So this is image dims get 0. Uint n, okay. We have the kernel, so that has to come in here as well. Let's assert for now that the kernel dims len equals 2. Yeah. And we also want to check that the or that the dimensions are not the same. And while we're here, let's also check that kernel dims get 0% 2 is equal to 1. Right, I just want to make sure that it's like odd size, because I don't really know what happens if they're even size right now, and I don't want to think about it. So we'll just say that they have to be odd. That's like a restriction that we could probably lift later. Probably. So now we have a kernels. I guess the word kernel is overloaded here, so let's call this image kernel here. So here we have image dims num elms as our n. We are running the conv masked conv kernel buff mask ret image width number of elements that we're running. Then we have the image kernel buffer here with our kernel width. Okay, and the divisor, which I guess comes in here as a float. Like this. Okay, we need our output, so we need to do like create. Oh, we have self create tensor uninitialized, so I guess we kind of do that with image dims. Kind of copy that shit. Okay, and then I guess we just return ret here. Yeah, that's a maybe. And if we want to execute this during image generation, now this means that our barcode generator no longer can just like overwrite the underlying tensor that he was working on, right? This is like base, and he's gonna return a tensor here. Right, so I guess we are allowing him to like fuck up the base. Note, base will be overwritten in first pass smile, right? Maybe that's fucking stupid. Maybe we shouldn't be doing that. Fix me. Maybe we shouldn't do that. Maybe we just shouldn't do that. That's fine. So let's do pass one out is create tensor uninitialized, I think is right. And his dimensions are just going to be match the input dimensions. So pass, which means that this like barcode generator kernel should actually be sampling from image in. So we can just go like image in global ID. Just kind of unconditionally do this. Just so that early, early returns don't fall over. Kind of bad for, maybe causing extra memory IO, which could be bad, maybe. I don't know, whatever. So this guy wants image in now, so we have base buff, pass one out buffer here. And then we have pass two. So pass two is we take pass one and we want to do a mask conv on this guy. So before we do this though, can we just return pass one out here just to make sure that this is still working the way we expect? So when we generate images, we have update somewhere on this guy, and we want to take this as the like. So this is the input image. Then we have the output image. Now everything should still be working the way it was before, but it's not. Because what? Conv CL mask conv does seem right. He doesn't like this. He's not like complaining about. Oh, I spelled mask wrong. Hard life. Okay, so this is still working, which is good, right? So now we should just be able to do like the second pass. So the second pass is self math executor mask conv. So we have our mask and our image. So we have pass one out mask. We need to create our image kernel, which we'll figure out in a second, and the divisor. So can we do something like make blur kernel And we pass in probably some shit. Like, surely this is gonna make like CL alloc. And here we probably have like params uh like we probably want size plus like the Gaussian fall off, right? So if this thing's supposed to be kind of blurring like according to, you know, this, we probably want like the standard deviation. Mean, I think, is just always going to be 0. Wait, so how does this, hold on. So we have some hump. How does like the blur even work? We have some hump, right? And I guess like for something really, really thin, the area under this curve will be like 1.0, like right on the center pixel, right? But as we get like a fatter and fatter, we're trying to take in like more of our surrounding pixels, right? So this is going to be kind of like a 3D hump, I guess, right? We're gonna have like plain. This is like the kernel, and he kind of looks like this, right? You know, like kind of like a little hump coming up from the center. And the area under that whole like 3D guy will be 1.0 ish, you know, hand wavy. And I guess we probably just define the width of the thing by the kernel width, right? So we probably are like trying to do something like, if we're doing a 5x5 kernel, we probably want like the overall sum of everything to be like about 1, right? So we probably do like the 3 standard deviations shit, where 3 standard deviations is essentially like everything. And so the standard deviation is defined by the kernel width. Sure. Blur kernel size. I think that's reasonable. Yeah. And then blur kernel divisor actually should be 1.0, I think, right? Because if the sum of all elements of this thing are like sum to 1, then we don't have to worry about going over. In fact, we probably will get a very, very slight dimmer, maybe. But we'll see. Okay, make blur kernel. Returns a math tensor. I don't really like this, by the way. It's just kind of like, this is, we have like a tensor type that has any backing store because it's used in like back propagation graph tracking as well, right? So it's just kind of like confusing to have this guy live in math executor, but this is like the one that's backed by just an OpenCL buffer directly. Okay, self is our barcode generator, probably, and alloc, CL alloc is a CL allocator, and we have width, U32, probably. The divisor you set in the kernel is kind of enforcing unit sum on the weights that you give for the convolution. If I set 1.0 here, I had this like provisioned for what if we were to do like a blocks blur or something, like maybe we don't want 1.0 here all the time, but we could just always set kernels where we don't need that. I don't know. We'll see. Okay, so I assume that if you're doing 2-dimensional Gaussian, it's probably you just multiply one by the other. I don't really know if that's true, though. Can we go to, like, normal distribution? Does this talk about, like, moving up to higher dimensions? The Gaussian has the property of the 1D Gaussian to slice the 2D Gaussian. Yeah, that makes sense. In which case, multiplying does also make sense. But what I'm not sure is if I multiply the two together, if like the area under the 3D curve is still 1.0. You know what I mean? Can we just ask ChatGPT? I don't really know. I don't want to fucking Google this shit. If I want a 2D Gaussian surface, if I multiply, like, how do I generate from a surface with a volume of 1.0? I guess it's kind of like 3D, huh? From one, yeah. Can we just do this? We'll just ask him. I'm not sure what you mean by multiply them together. Just sample them separately. But you have like one height for X and Y, right? Am I fucking stupid? Right? Like, if my X curve looks like this, and I'm coming like this, like in and out of the page, like it's gotta get like smaller and smaller as I get farther away, right? Till it's like basically nothing. So you can't just they're not independent. They're like together in some way. I'm assuming that you just multiply, but interesting. So he's kind of extended the existing function to more dimensions, right? So he's taken this and he's just thrown in like an extra dimension here, right? So instead of like, and there's like a 3/2 for the power of this thing instead, is what he's saying. If you meant a 2D surface of the volume of this in 3D, so you hear he's kind of doing, it's again kind of the same. Yeah, very similar. Can we look this up? Sample separately, this means what it means to slice. But you sample separately, then what? You have two numbers now, right? Then you need one number out of the two numbers. Am I crazy? You need one number. Each spot in the kernel has one. If I'm generating an image blur kernel, each cell in the kernel is one number, right? The amount of that pixel that you want. And so like you have two dimensions, you need one number out. Where does it come from? Where do the numbers come from? You know? Multivariate, there we go. Normal distribution. This is actually probably what I was looking for. Yeah. Yeah. This is probably it. Yes, it is the product because x negative x squared y squared is equal to this. Sure. I mean, I hope that's right. There is 2D case described. Oh yeah, nice. This, right? Dude. Kill me. Dun, 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 dun. This is like, oh, I guess because here they have different standard deviations for x and y. But I'm kind of okay with it being singular. I guess we can just try doing it in one dimension twice and multiplying if I think that's right, and then summing that and making sure it's one. Yeah, okay. I'm pretty sure that's right. We'll figure it out. I just hard code the 3x3 or 5x5 kernels. That's pretty reasonable too. So this is like uh okay. Sample normal dist. I think we have this somewhere. Probably in like math executor. Normal dist at. Okay. You guys are all talking about covariance matrices, dude. I don't know what the fuck that means, but I believe you. Um, so I guess, um, if we have like a 3x3 kernel, it's like we're trying to make it so that, maybe like we have a kernel like this 3x3. Boom, 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 boom. If we want kind of like this range to be almost everything, this should be like -3 standard deviations, and this should be 3 standard deviations. This should be 0, I think. And so, what if it's like 5x5? It's like the same thing where we want -3 here, 3 here, 0 here, and we just like divide in between. Um, right, so it's like -1.5 and 1.5, I guess. Okay. So, we go like assert that kernel width is odd because I don't know what to do otherwise. We want to sample the normal distribution at like, I guess it's like 4, 0 to kernel width. Y. X. Normal X is normal dist at. So it's like kernel width over 2 is something relevant. This is like max distance. And so we want center. I guess this is kind of like kernel center. So it's like X minus kernel center, which means that we want this to be as like I32 probably. Xi is int from like int cast. X, we do like xi minus kernel center is like the x offset. Then here we need to convert this. We need to like multiply this by 3 over kernel center. Yeah, so then we do like x offs times equals 3, and divide equals kernel center. Yes. So here we'll just say, we want to get 3 standard deviations away. Multiply by 3, divide by kernel center to get 0 to 1, multiply by 3 to get 0 to 3. Okay. I think that makes sense. And I guess we want to do like kernel offs to normal dist x. Takes in kernel width. He takes in the offs and returns a floating point number. Or we could just do like, maybe we even just say like, kernel sample normal dist. I knew a Ken Rel. He was the center of a controversial bug. Hell yeah. Okay. So maybe here it's not even off. We take like index. Yeah, and so then we like convert to an integer. We do all this here. He doesn't see it. Yeah, I'm assuming that I wrote Kenrel somewhere. Fine. Fine. Okay. Here we go. So, normal dist at x offs. I think. Think it's all we're gonna do here? I think. Maybe. And then let's look at this guy and we say like x norm is kernel sample normal distance. This is y norm, sorry. Y and kernel width. And then we sample at x and kernel width. Okay. Yep. And then we have we probably allocate some floating point values of kernel width times kernel width. We do this on heap because when we upload this thing, it's actually going to go out of scope because we're not going to wait for the GPU to get the data before we return from this function. So it has to live somewhere else. And so it's like kernel CPU at y times kernel width plus x is equal to x norm times y norm. We're kind of hoping that this is how this works. And then we return self math executor create tensor untracked cl alloc, and presumably we upload the kernel as well here. Yeah. Kernel width by kernel width. Okay. I'm kind of hoping this works. And while we're here, we can go like for kernel CPU, we get the value. Var sum is a floating point 32 equals 0, and we say sum plus equals v, and we can just double check that this is approximately right. This should be around 1.0 if we're lucky. Okay. Sure. So blur kernel size does not exist. And can we just do like a... I don't even want to deal with randomization here, to be honest. Maybe what we do is we have a blur kernel multiplier that shows up. Yeah, then we can like kind of reduce the effect of the blur if we want to. Which could... Yeah. Which can manifest as like a divisor change. Okay, yeah, we can start here though. All right, let's see what happens. 3x3 kernel, please. What's it pissed about? Yeah, that's true. This thing should be failable, almost certainly. Damn, I got from it to kill Ken. Sorry. We'll bring him back. What is this guy pissed about? Probably like an incast here. Uh, little float cast. Okay. True that we need to write try on heap allocations, or else they get angry. He's mad because mask conv did not pass enough parameters. What I miss? The allocator that this thing's gonna go on. True. Oh, this should be like this, not equal to 2 like this. That's easier. Blur kernel size is 3, hard coded, I guess. Okay. Sum is very low. I do not like that. Not a fan. Not a fan. So it kind of makes sense. I mean, so it's possible that like I fucked this up in some way. Yeah, because like we're just sampling at points, which seems bad. This 3 standard deviations thing does not actually make that much sense. Because if we go times 3, we're getting to like the very bottom. We're like sampling like the top and the bottom, which is like basically nothing. We want to sample like halfway to the bottom, probably. Maybe. Or we want like the integral of like all space between the last point and us, right? If we're like, I guess what we kind of want more realistically is like if we're chunking this guy into 3 chunks, we kind of want like the middle section, and then we want like this area, and this area again, which is like not really reasonable. Why doesn't your LSP complain? It does. I just ignore it. So I mean, really, I guess just like sampling in the center probably makes sense. So how do we do that, right? If we're chunking this into, you know, we have like -3 +3, and we're trying to chunk this thing into like n chunks, right? So we have, you know, some amount of things between here. So we probably just add the width over 2 or something. It's like sample width is 6 over kernel width or something. Yeah, because the kernel width is like 5, so the width is one of these things. And then this guy is sample width over 2. Sample from the center of the segment of the Gaussian. And then we probably like multiply by that thing as well, right? If we're trying to approximate the area onto the curve. I think that's right. Why is this so hard? Can we print the kernel? Can we do like, how do you do decimal formatting in this language? That's what, right? So the fact that it's not symmetric is fucked up. Like, what is happening here? The bottom, like, y is surely just not doing what we need it to do, right? What in the fuck? What the fuck? That's weird. I would think this should be perfectly symmetric, unless we fucked this up somehow. So, can we GDB this? He takes a while because he's like, I think GDB like freaks out when all of the OpenCL stuff is loading. Okay, kernel center is 1. That is correct. We have our x is 0. So we are -1 away from the center. Okay. Our sample width here is 2, which is correct because there's 6 total in the thing. Yeah, our standard, like this whole area is 6. So our sample width being 2, it makes sense if we're chunking it 3 times. Okay. So now this sample is sampling from -3, but that's the wrong spot. So we add the sample width. And then what does this divide for? That seems fucking stupid. Oh, because we're trying to get in the range. Zero to 3. And our kernel center is 1. Wait, so that should be fine. Okay. So kernel center is 1, so this does nothing. Okay, so that seems reasonable to me. So can we, can I call this stuff? Does that work in here? No. Can I call this? No. Fuck. Okay, can we just do like... I don't know, I just want to like start looking at this to see if it behaves the way I expect. So like 0 and 2 should behave the same. So let's just like 0, 1, 2, just log them all. Oops. Because I think that was right. Oh, we don't need to really listen to GDB, which is slow. Oopsies. Zig build, delete this shit. Okay. Yeah, so what the fuck is going on here? So we have x offs is 2 minus 1. Oh, maybe it's this. Yeah, we need to move it like in, which is confusing. Yeah, so what is happening here? It's like we start here, and the distance from here to here is now no longer what we expect. So this is not supposed to be times 3. This is supposed to be times 3 minus like this distance, probably. So minus 1 sample width. That makes more sense. So now these are still not symmetric, which is bad. But I think like the idea there is close, right? We're trying to sample like this square, this square, this square, right? So what am I missing here? We are moving so our sample width 6 over the kernel width. That makes sense. Our sample width is 2. Here we have our offset from the kernel center. So are we just doing too much here? We can just like multiply x offs times sample width minus sample width over 2, right? Yeah. Does that make more sense? And then it's not just minus here though, because we kind of want to go like towards the center. No. It is just the same, not even this. We just fucking move x offset times sample width. So x offset will be like 1 times the sample width, which would be here. Yeah, what the fuck? We're just making our lives harder than they need to be. Okay, now at least the numbers are symmetric. But now, like, the overall values are really small. Shouldn't index go between negative kernel width over 2 to kernel width over 2 instead of 0 to kernel width? It's kind of like the same. Hand wavy. They're the same as long as you do the subtraction. Okay, so can we like multiply this by a lot? Because like even this, like in one dimension, even though the area under the full curve should be 1.0, because of the sampling, it's not, right? Like we're losing all of this space by doing this. So can we just look up Gaussian blur image kernel? Like, where does this come from? Am I doing something fucking stupid? Sick output, bro. I don't really want. This isn't helpful. Um. Blah 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 blah. Okay. Um. 0, 1, 2, baby. Um. Compute one value for each element in your kernel. Maximum weight to the central element in your kernel, and value is close to 0 for the elements of the kernel borders. Implies the kernel should have an odd height. Blah 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 blah. So what is this guy doing? He's doing like something similar to what we were trying to do, right? He's got Gaussian. He's multiplying the like two versions together, like we were doing. Ah, this is clever. So he's calculating the sum. and dividing by that at the end, kind of saying like, yo, this thing is like not normalized to 1, but you can normalize it to 1. That is not crazy. Not crazy. So, does that look kind of right? Maybe. uh, can we look up, like, image kernels? I've seen this on Wikipedia. Like, let's, like, look at, like, these guys have a 3 by 3. Can we, like, multiply this by 4 and just kind of see if the numbers line up? Uh, oh, oops. So ours is quite aggressive compared to what they have. But they also are approximations. I guess maybe we kind of have the choice now to not define the width, the like sigmoid by the width. Right? Like we could like kind of sample from like less of the width or something. Right? Which would kind of like make this kind of fall off slower, which is maybe useful. Right? So we could say we could do something like this. Not sigmoid, fuck. This is standard dev. I just fucking, it's in my brain that way now. It's broken. You know? You could do something like this. Oh wait, we lost the part where it normalizes. And I guess we can just start playing with these parameters and see what happens. So we could have, wait, what's he pissed about? Invalid dims? Who's mad about that? This is at make bars masked conv. And he is mad at he's mad at 281. Kernel dims.length is not equal to, or the dimensions are not the same, or they're not odd. Oh, not equal. Oopies. Okay, bad news. That's funny. So, with our masked conv, we need to, pull from the background if it's there. Yeah, so we need to go, like, into, if this is less than that, outbuff global is equal to inbuff. Like this. Whoopies. Okay, so now we should start to see some blur here. So we could do things like, let's like set the blur kernel size to 5 for a second. And can we add in the blur standard deviation here? And we should be able to like increase or decrease this and start to see more or less of an effect. That's kind of what I would hope to see here. So can we kind of throw maybe blur params on here? And we'll make a float dragger for blur standard deviation, generate blurs to dev, which means that this guy needs like blurs to dev, which means he needs one of these. Blurs to dev val, and then we need to handle that thing. So blur standard deviation says, yo, could we change the blur standard deviation and update that shit? Cool. Then in the barcode generator, we need to use that thing. Whatever. 3.0. Fuck it. So wherever the fuck we pass in that 3.0, this needs like params, blur, standard deviation. Uston, thank you for the tier 1. So we should be able to be like, reduce this guy. Yeah. Nice. Yeah, so you can't see this having an effect, right? So as I decrease this, it gets more blurry. Look at that. Blurry, not blurry. Blurry, not blurry. Blurry, not blurry. Blurry. Sick. Sick. Oh, and I think I also I might have forgot to thank Ice Leo earlier for the 5 gifties, but it's very much appreciated. Cool. I think that seems kind of hype. I think this is a good place to call it for now because we're at 2 hours 20. I didn't really have much cleanup work I wanted to do. But this is pretty hype. Pretty sick. We might have to like clean up the edges here. We might want to like here we might want like a less aggressive like border between it and the background. I'm not really sure. Right? It's kind of weird that it's like blurring in from the outside but not vice versa. But at the very least like the bars themselves are like starting to look pretty good. Cool. Thanks for watching, guys. If you like what you saw, we stream most days. We aim for 12:30 start and we end somewhere around 3 or 4. It is 3 now. So if you're watching live, anywhere between 3.5 hours ago, or sorry, 2.5 hours ago and an hour from now is when you should expect to see us live. We're working on this neural network barcode trainer thing. There's a lot more to do. We're having a lot of fun. Yeah, so we'll be back. You know, some segments of the stream, some streams go up on YouTube, some do not. The reason for that is because we want something to give people who want to support the stream. So the other parts that don't go on YouTube go on Patreon, YouTube members, or on Twitch. And so if you subscribe on those platforms, you get the knowledge that you're helping the stream continue because it will end when I need to get a job. And, you know, you get access to the VODs that we don't post. I think that's it. YouTube, peace out, and Twitch, let's find someone to raid.